for our second question, a curve has the equation given where x has to be greater than 0. We're doing some differentiation to start with. So dy dx equals 2x minus 6. The 25 will go. If we rewrite this as 32x to the minus 1, it's a little bit easier. So it's minus 32 if you bring down the minus 1. So minus 32x to the minus 2. Find the second derivative. So we go again. So this is going to be a 2. The minus 6 will sort of differentiate away. Over here, we're going to have minus 32 times the minus 2 is plus 64, 64x to the minus 3. It is claimed that C has a stationary point when x is 4. So a stationary point means that it should give you a gradient, specifically a gradient of 0. Verify that this is correct. So to verify, we are allowed to sort of use the result and show that it works. So let's change the notation. Let's try doing this one here. Let's try putting 4 into the derivative. So what would that look like? That would be 2 lots of 4 minus a 6 minus 32 lots of 4 to the minus 2. So this should give us a 0. So it's 8 minus 6. We'd have to do this bit first, which is, what's that? Well, that's 16, and then it's 16 sort of in the denominator. Okay, so you can see that that is in fact going to give us 0. So for verifying, we're actually supposed to sort of use the result. That's why it's so few marks. We're supposed to use the results. Determine the nature of this stationary point. Well, now that we know it's a stationary point, the choices are it could be a maximum, a minimum, or it could be a point of inflection. So if we look at the second derivative here, that should tell us a little bit more. That's one way that we could do this question. So we're going to now use this one instead, and we're going to use the same value again, and we're going to see what happens. So for our notation, we're going to look at 4. So that would be 2 plus 64, 4 to the minus 3. So 4 to the minus 3 is going to be a 64, but sort of in the denominator. So it's going to end up being 2 plus 1, which equals 3. So when we have positive values, so a positive value means it is a minimum. And if you want to know the idea for that, the idea is that when you have this situation here, if you imagine lots of tangents, the second derivative looks at how the tangents change. So they're changing in a positive way. It means it's sort of turning around, if you like, I suppose is the easiest way to think of it. So that's our second question.